Okay, we're looking at 26.84. We have a resistor, and we know its resistance. It's connected to plates. This time it's a charged capacitor we're looking at. Okay. And we don't have a battery connected to it. Again, we know its capacitance written right here. It's 4.62 microfarads. And before it's made, we know the charge that's on it. Okay. First thing we want to know is what is the energy initially stored on the capacitor. Well, that is just going to be, again, we're not going to use the resistance to figure that out. We're just going to use Q squared over 2C. That's going to give us the amount that's in there. Again, they tell us that it's 8.1 microcoulombs, so times 10 to the negative third, maybe, divided by 2 times 4.62 times 10 to the negative 6 farads. We multiply, oh, that just didn't work out there. There we go. Oh, okay. We multiply all that stuff together and we get 7.1 joules. Okay. All right. For B, they ask us what is the electrical power dissipated in the resistor just after the connection is made. So we're looking for power, which means since we have the resistance, the easiest way to find it is to use I squared R. And we need to use the current at the very beginning. Well, we know that for any of these, it's going to be that the instantaneous current is going to be the current at the beginning, e to the negative t over RC. But this is 0, which means this whole term turns into 1, and it's just going to be that. Okay. And if we solve for that, remember that it's going to be Q over RC. Okay. You can actually reason that out by looking at the units. The units are, I'll do that over here. That the units for Q are coulombs divided by the units for resistance, which are ohms, but that means, remember, volts per amp, times the units for capacitance, which are farads, which are coulombs per volt, okay, which means the volts are going to divide out. These coulombs are going to divide out. 1 over amps is going to give me amps. So I'm going to end up with amps for my unit for that. So all I really have to do is multiply all those numbers together. Okay. So I'm going to use 8.1 times 10 to the negative third coulombs. I'm going to divide that by that resistance they give us up there, 850 ohms. And I'm going to multiply that times the capacitance again, 4.6. Remember, it's microfarads, so times 10 to the negative 6 farads. I multiply all that stuff together and I get a number of 2.06 amps. Okay. So now I know the current, which means I can put it back up in this equation over here. So I'm going to bring this stuff all the way up here. Okay. And I'm going to solve that. So this is going to be, and I'll bring that down here. So it's going to be 2.06 amps squared times 850. And that is ohms. If we multiply all that together, we get 3,616 watts. There's a couple of ways to do part C, where they ask what's the electrical power dissipated in the resistor at the instant that the energy stored at the capacitor is decreased to half the value calculated in part A. Okay. There's a couple of ways to do it, and I'm going to actually reason through it rather than calculate it. You can actually calculate this number out given all the information in the problem. Okay. But I'm going to reason through it. Okay. So I'm going to say that like when you have half the energy, so the the energy in it is going to be the energy at the beginning divided by 2. Well, if that's true, and I go through and I say that's equal to U equals Q squared over 2C, well, if I cut this in half, when I cut that in half, this is going to get smaller too, but by a factor of √2. So that means that the new Q for the half-time is going to be Q naught divided by √2. So it's going to get a little smaller there. Okay. You can reason that out if you just put in like √2 for that. Okay. Remember we said earlier that the current was Q over RC. So that means that the new current is going to be at the half mark is going to be Q naught over √2 RC. So again, it's going to be √2 of what we expected for the answer last time. Okay. Then, and again, before it would have just been the Q naught divided by RC. And if we go back to our, if we go back to solving for our, power, it's going to be I squared over R. So it's going to be I squared, or sorry, times R, my fault. And then that's just going to be Q naught squared over 2R squared C squared. So I can write that in. I think I have to move this to do that. So let's rewrite it over here. Q squared over 2R squared C squared times R. So one of these goes away. Okay. Now before that's 0 over here too. Okay. Now before that would have been Q squared over R squared C squared times R. We have an extra half. So it's going to be half of what it was before because we have this extra 2 over here. You can see. So that means that our power is going to be half of the power that we had when we first plugged it in. We know what that is. We got that before. We got that it's going to be half of 3616, and that's going to be 1808 watts.